Hello, it's Ryan. Today we're going to have an introduction on forces. This is kind of the next segment of our class where we're going to begin studying both kinematics, which we've been doing, the study of motion without regard for its causes, but now we're going to be adding on to it the dynamics of situations. And so we'll recall that dynamics is the study in physics. Well, really, it's the study of motion with regard for its causes. And so we'll just note that one more time. We did mention this in one of our first lecture videos. So this is with regard for its causes. And when we say its causes, what we really are saying is we're going to be looking at external forces now. So we could even note that in dynamics, we study bodies. We study the external forces acting on bodies that will change or cause a change in motion for the body. In dynamics, we study the external forces that cause a body to change its motion, or that cause a change in motion. What's another word for change in motion? Do you remember? Change in motion is just our fancy way of saying acceleration, isn't it? In order to really understand forces, I think it's important to discuss just briefly, since we don't have a class time. I'm not going to tell the whole story, but I want to just call to reference Sir Isaac Newton. He's kind of like the godfather of forces in a sense, but don't quote me on that. I don't think that's something that's often said. Sir Isaac Newton, he was born on Christmas Day in 1642, and he died in 1727. So he had a decent life. And a lot really went on for this guy. He was a weird guy. He had trouble in school for a while. And anyway, in 1666, he was working as a professor at Cambridge, but Cambridge was in trouble. I don't know if you're big in your history, but at that time, Cambridge and most of England was being affected by the Black Plague. And so Isaac, realizing that where there were a lot of people were dying, decided to write his grandmother and move to her farm if she so allowed it. So after writing to Grandma, she said, "You can come on by if you help with the farm work." And Isaac said, "That's fine. I'm just going to take up one of your sheds in the back." And so he moved into Grandma's house, and Grandma lived in Woolsthorpe by Colsterworth. That's just a town. Woolsthorpe by Colsterworth, and it was at Grandma's farm, where he was hiding from the Black Plague, that he made some very important discoveries. And so we're going to say Isaac's discoveries. Isaac's discoveries. So one of the things that Isaac discovered was that white light was not pure. Before Isaac, or really up until Isaac's time, everyone knew that white light was the most pure form of light. Roy G. Biv is that guy that represents the rainbow, right? What he discovered is that if you break white light up into what it's really made of, you would see the rainbow. Red, orange, yellow, green, blue, indigo, violet. So this was a big deal. Before Isaac, everyone knew white light was pure. And red light, for example, would be a dirty form of white light. And it's just the opposite. He did a lot of strange experiments to discover this. One of the things he would do is he would take a piece of wood, he called it a bodkin, and he would carve it into a shape like that. And then he would take this part of the bodkin and he would open up his eyelid and he would put this part of the bodkin behind his eyeball and he would use it to tweak his optic nerve. He was a weird guy. Anyway, his second discovery that was pretty major is a little thing called fluctuations. But none of you have probably heard of fluctuations. It is really referred to as something different now. Any guesses? That's right, calculus. He discovered calculus, and I like to say discovered and not invented, because it turns out, as Isaac was coming up with calculus, two other people were independently doing it, one in Germany and one in China. There's a little story that goes along with Isaac's discovery of calculus that really indicates the kind of person he was. He wanted to be the only one that could do calculus, and it wasn't until he heard through the grapevine of this German mathematician that has come up with the mathematics of motion. And he said, I came up with that first, and he published his work. So it's kind of up in the air who really came up with it first. I like to think that they discovered it serendipitously at the same time. Anyway, he came up with and discovered the mathematics of motion, which we now call calculus. The next thing, and probably the most important discovery he made when it comes to physics, and our class in particular, are his 3 laws of motion. His 3 laws of motion, and we're going to talk about those in depth in just a little while. The final discovery I always like to bring up is called new log, but what that really stands for is Newton's universal law of gravitation. Newton's universal law of gravitation. That's right, he discovered the force due to gravity. We've all actually kind of independently discovered that by sticking around on the planet even if we didn't want to at the time. But he's one of the first, at least, that we know of to really create some mathematical language that describes that force created by our Earth. And we'll definitely talk more about that as well. But those are his most important, at least arguably his most important discoveries. And for our class, the most important of this list will be the 3 laws of motion. But Isaac was a weird guy. So in order to really discuss his 3 laws of motion, we want to get some definitions down. We have a few definitions to discuss. So I'm going to give you those first so we can all be speaking the same language. So we have to do some definitions. So the force is the first definition, but we're going to actually save that for the end. So the first definition we're going to do is uniform motion. Uniform motion. The next definition we're going to do is acceleration. Okay, so we should just define them as we move on. So uniform motion, that is anytime motion is unchanging. So I think that'll work. Anytime a body, or we'll say a body's motion, is unchanging. So right now, if you set your writing implement down on the table and it's just sitting at rest, could we say that that pen or pencil is in uniform motion? And oftentimes people would say no, because it's not actually moving. It doesn't have a velocity, or it has a velocity of 0. But that's just it. It has a velocity of 0, and it's just sitting there like a house on the side of the road. So it is in uniform motion. It's just uniformly not moving. Anyway, uniform motion is whenever a body has unchanging motion. Acceleration is then a change in motion. Anytime motion changes, that means that the body that's motion changed experienced an acceleration. Okay, next is inertia. Inertia for short. Inertia is something that's often misused or misunderstood in physics, and so I like to define it for everyone. Inertia is the tendency or quality, and that only has one A in it. The whole thing I just said, quality has the A in it. The tendency or quality a body has to resist change in motion. That's really what inertia is, the tendency or quality a body has to resist change in motion. Next, let's define mass for you. I bet someone in your life has defined mass as the amount of stuff in something. Mass, in physics at least, is the measure of inertia. The measure of inertia. And finally, action. And force. Let's define those. So when Isaac Newton defined his 3 laws of motion, he used the word action instead of the word force. So if you see action in any physics text, all they're really saying is force. And force. This is really the most important definition, perhaps. They're all important, but this is a very important definition that you must try to leave this class remembering. Have you ever had someone define for you force before? I would imagine that it was probably at one point in your life told to you that a force is a push or a pull. And I'd like to say that though forces can be in the form of a push or a pull, that is not our definition for a force, and so I'd like us to have a better definition. A force is an agent that causes change in motion. An agent that causes change in motion. So that is, I think, the best definition of force that you're going to find out there. So we needed these definitions to really discuss Newton's 3 laws of motion, which I'll discuss and give you now. The first law, we often will write N1. This is often called the inertial law. The inertial law. And what this law says or states is that an object in motion, and we'll say in uniform motion, an object in uniform motion will remain in uniform motion until acted on or unless acted on. So I think I'm going to say until acted on by some net external force. An object in uniform motion will remain in uniform motion until acted on by a net external force. Sorry, I just get so excited with his laws. So there you have it. Now, I'd like to just mention that this law is much more innovative than you probably think. What you could do to really prove to yourself how innovative this was is you could do a little experiment. So before Isaac came along and created this idea here, everyone in the world went by what the Greeks had first decided was the law of motion on this planet. And that law of motion was that everything's natural state is at rest. And that's what everyone believed before this law. And the way you could show that kind of to yourself is you could just take a handful of things that won't break, like markers or pens or something, and just toss them in any direction. And what you'll see every time is that they'll come to rest. And so that was enough support, especially in Greek times, to say that that's the law of motion in the universe and on our planet, that objects tend to want to be at rest at all times. Well, Isaac came along and said that's wrong. He looked at thousands of years of experimental evidence and said, I'm sorry, but you're just not seeing it right. This is how it works. An object will remain in uniform motion unless some external force comes along and acts on it. So this was a big deal. The next law, N2, Newton's second law, is the force law. And the force law is best represented mathematically. What it says in English is that the acceleration of an object is directly proportional to the force on that object and inversely proportional to the mass of the object. But mathematically, it just looks so nice. F equals ma. Oh, and I think we brought this up in the past. So we could just define where F is the net external force. So another way to write this law, you could write F net, or you could write the sum of the forces like that. Those all say the same thing. M is the mass of the body, and A is the acceleration. So that's Newton's second law. Believe it or not, that's what almost our entire class is based on. Well, really all three of these laws. We're going to do plenty of examples and show you how we really utilize Newton's second law. So don't let this scare you. This is the basis for the rest of the mathematics that we'll do anytime we need accelerations. The last of his three laws is the action-reaction law. And this is maybe one of the most quoted. I don't know. I think all of his laws are quite often quoted. But the action-reaction law states that for every action, there is an equal but opposite reaction. Well, we don't want that comma there. An equal but opposite. And perhaps we shouldn't say but. No, I'll leave but. But opposite reaction. And if you recall from just a little while ago, we defined the word action for you as force. And so really, this is like saying for every force, there's an equal but opposite force. And that's Newton's third law. So one of your major goals in this class is trying to truly understand that these laws, these three little laws, apply to any moving body in the universe. At least that's what we think in physics. And so anytime you see a body with changing motion, you should be able to describe that changing motion using these three laws. It's very important, and I guarantee that you'll be asked to do such a thing on quizzes or tests. So, an example that we usually would do in class is that I would throw a ball against the wall, and we would together use Newton's laws to describe it. So maybe that would be something that you try to think about. If you were to throw an object in the real world, how do these three laws of motion apply to the ball changing motion? And maybe to you as well.